Here is proof number 1. First of all, we have the given. Second step, since E is the midpoint of DF, that means that this segment is equal to that one, and we'll say that DE is equal to EF, and the reason for that is definition of midpoint. So we've used this first part of the given. Now we have the second part of the given where it says F is the midpoint of EG. That means that EF is equal to FG, and the reason is again definition of midpoint, so we can keep it in that same step. Step number 3, I'm going to look at my prove statement. I want to get DE equals FG. So here is segment DE equal to EF. Here is that same EF equal to FG. So then we can say that DE is equal to FG, and that is by the transitive property. Proof number 2. Once again, we're going to start off with the given. And this time the given doesn't give us an equation to write down right away. There's no action we can get out of that. So we'll go to the prove statement, and it says we want to prove that segment KL plus segment IJ is equal to the entire segment HJ. Now if you look at those two segments, they're not even next to each other. But if we look at the proof statement, we're trying to match it up as closely as we can. So we'll look at where segment HJ is located and look at the two segments that make up that segment. That would be segment HI plus segment IJ equal to HJ. In other words, these two segments added together make up that whole segment. We call this the segment addition postulate. And this statement is almost like our proof statement. There's one small difference that we have to look at though. Instead of having HI plus IJ equals HJ, it says KL plus IJ is equal to HJ. In the given, we're told that HI is equal to KL. So we're going to rewrite step number 2, and we're going to put KL in for that HI. And our reason for that is substitution. The substitution property of steps 1 and 2. Step 2 is where we got that equation from. Step 1 is where we got the fact that HI and KL were equal to each other. So here is our proof number 2. Proof number 3. Once again, we'll start off with the given. The length of segment AC equals 14. The length of segment BD equals 14. Well, since they both equal 14, I can combine those together using the transitive property to say that segment AC is equal to segment BD. Okay, so we have that part of it down. Next, we're trying to get segments AB and CD involved in this proof. So as I look at that, here's AB. I have AC mentioned. So I'll say AB plus BC is equal to AC. And the reason for that, again, is the segment addition postulate. So I have AB involved in the proof now. I want to get CD into the proof. So here is CD. I already have a statement about BD in there earlier. So I'll say that CD plus BC is equal to segment BD. And that's also the segment addition postulate, so it'll stay in step 3. Next up, since we have this earlier statement that says that AC is equal to BD, we're going to combine this gray, which is equal to AC, and here is AC equal to BD. Here's BD again equal to this. In other words, all of those gray highlighted things are equal to each other. So then using a transitive, we can say that AB plus BC is equal to CD plus BC. And again, that's a transitive since all those things were equal to each other. Step number 5. We're pretty close to having what we want. We want AB equal to CD. And in this equation, we have AB on the left, we have CD on the right, which is great. However, there's a little bit extra on both sides. So what we're going to do then is say that BC is equal to BC. The reason why we can say that is because of the reflexive property. More importantly, the reason that we want to say that is because then we're going to take step number 4, subtract step number 5 away from it. So if I subtract BC from the left side of the step number 4 equation, I'm left with AB. Subtract BC from the right, and we have CD. So our reason is the subtraction property. And we subtracted steps 4 and 5, so we'll put those in parentheses. And this is what we were trying to prove, AB equals CD. Here is proof number 4. We're given that RS is equal to TU, so these two segments are equal to each other. And we're trying to prove that the overlapping segments RT and SU are equal. So I don't have an equation that I can set up right away from the given. However, if I try to combine the given and prove into one equation together, I see that I can do some segment addition. RS plus ST is equal to RT. And I also can say that segment TU plus segment ST is equal to segment SU. And again, that is the segment addition postulate. The reason why that's significant for us is because as we compare those two equations with each other, there is going to be a connection between them. I don't have that RT equals SU yet. However, I know RS equals TU, so if we look on the left side of these equations are almost the same. What I'm going to do though is I'm going to change this equation and make a substitution. Since RS equals TU, I'm going to put RS in for that. So RS plus ST equals SU. That's a substitution of steps 1 and 2. And where that substitution came from is the fact that RS equals TU. I took this TU out and I put RS in for it. Next step. I'm trying to get RT equal to SU. Well, here is RT equal to this whole expression. And I see that exact same expression right here. So RT equals this, which is down here, equal to SU. So then connecting those together, we can use the transitive property to say that segment RT is equal to segment SU. And since that is what we were trying to prove, this proof is over. And here is proof number 5. We have our given, we have our proof statement. The given doesn't lend itself towards getting any equation directly from that. But if we use a strategy of looking at the proof statement and trying to come up with something close to that, we can get a start to this proof. I want two angles added together that make up angle CBD. Well, here is angle CBD, and the two angles that make up that angle are angle 1 and angle 3. So I'll say the measure of angle 1 plus the measure of angle 3 equals the measure of angle CBD, and we call that the angle addition postulate. Number 3. I don't want 1 plus 3 equals that angle. I want 2 plus 4 equals that angle. In other words, I want to take out this angle 1 and put angle 2 in for it. I need a reason for that. And if I look at my drawing, I can see that angles 1 and 2 are vertical to each other. So I can say that the measure of angle 1 is equal to the measure of angle 2. And we call that the vertical angle property. Next, from what I know, I want 1 plus 3 equals CBD. That's what we're trying to prove. I have 1 equal to 2. I can put that in there. I have 3 congruent to 4. I can put that in there. And then I would have my angle. So my step number 4 is to take out this angle 1 and change that to an angle 2. Take out that angle 3, change it to an angle 4, and it's still equal to the measure of angle CBD. The reason for this is a substitution property. We substituted the equation from step number 2, the fact from step number 3, and the fact from the given where we're told that those angles were congruent. And this is what we're trying to prove. And here is proof number 6. This time our given says that RT is the angle bisector of angle SRV, which which means that those angles must be equal. So we're going to say that the measure of angle 1 equals measure of angle 2, and that reason is the definition of angle bisector. That's what an angle bisector does. I'm trying to get angle 3 equal to angle 4, and right now I have 1 equal to 2. I need to get angles 3 and 4 introduced to the problem. So if I look at angle 1 and angle 4, I know that they must be equal. If I look at angle 2 and angle 3, I know that they must be equal. And the reason for that is because of their location. They're vertical angles, and so the reason we say that they are equal to each other is because of the vertical angle property. Next, I'm going to start making some connections. I want to get angle 3 equal to angle 4. So here's angle 3 equal to angle 2. Here's angle 2 again equal to angle 1. Here's that same angle 1 equal to angle 4. So then we can make the big connection starting at angle 3, traveling through all those equal signs, and we can conclude by saying it's equal to angle 4, and that reason is the transitive property. And that is what we're trying to prove.